All right, let's take a look at this problem here. They want us to begin by graphing the f of x, which is 2 to the power of x. So that's an exponential function, and we know what that's going to look like. It's going to shoot straight up. Use the transformations of this graph to graph the given function. Be sure to graph the given equation of the asymptote. So we need to put the asymptote in there also. Use the graph to determine the function's domain and range. If applicable, use a graphing utility to confirm your hand-drawn graphs, okay? And we can go to an online graphing calculator to do that, like from Desmos. So here is our g of x, okay? Here's our other function, and it's 2 to the power of x plus 5. This plus 5 is going to take this graph right here and shift it. Which way is it going to shift it now? Is this 5 up there with the x, or is it down here away from the x? It's up there with the x. Okay, so plus 5 with the x is going to move our graph 5 to the what direction? 5 to the left. Okay, shift 5 units to the left right here. And that's the only thing happening here. I don't have a negative in front. I don't have a plus out here. So we're going to shift 5 units to the left. Let's check our answer down here. Check answer. Excellent. Okay, now we have to graph it. Graph g of x is 2 to the power of x plus 5, and its asymptote. Use the graphing tool to graph the function as a solid curve and the asymptote as a dashed line. Okay, I'm going to click. Let's go ahead and click on the graph here. So this is my exponent, see down here? And if I leave it there, see what pops up? It says exponential tool. So I'm going to click that, and then really it doesn't matter where you click in the graph. I'll click down here. It's going to start you with your regular exponent. Okay, what your exponent looks like, where it shoots up like that. Now, we do we have a vertical stretch or shrink? I don't think so. Do we have a horizontal stretch or shrink? I don't think so. Are we reflecting about the x-axis? No, there's no negative. Are we reflecting about the y-axis? No, there's no negative. The base is 2. Okay, so what we need to do is we need to shift this 5 to the left. So to the left is not vertical, it's horizontal. So we are going to shift this. There we go. 1, 2, 3, 4, 5. Is that right? Let me go back to 0. 1, 2, 3, 4, 5. Okay, that should be it for this graph. But we also have an asymptote. Our asymptote was down here at 0. And that means that this graph never goes below 0. As far back to the left as you can go, it's going to get closer and closer to 0. It's going to get really close to 0, but it's never going to hit 0. So we need to do the asymptote. So here, down here, if you look at my mouse, this is the line tool. No, close that. Okay, this is the line tool. I need to click a line, and I need to click the dashed line. Okay, to do an asymptote, it has to be dashed. There it is. And now, this asymptote was right here at y equals 0. And that line has not moved up or down at all. So with my original graph, if I had taken this, let me go put it back where it was. Let me move it to the right so you can see. See how it gets closer and closer to that 0, but never hits? Okay, so my asymptote has not moved up or down. And this should be it. Okay, I have the graph, I have the asymptote. Let me check my answer, cross my fingers. Nice work. All right. The equation of the asymptote is, okay, and it's a line. It's a horizontal line. Remember horizontal, if you flip a y upside down, it's an h. If you flip a h upside down, it's a y. So it's going to be y equals, and then, whoops, y equals 0. Okay, no matter what the x is, the y is always 0. All right, if x is 4, y is 0. If x is 6, y is 0. So that's our equation of a horizontal line. Horizontal line is always y equals, and a vertical line is always x equals, with only one variable. The domain. So look at this graph. How far to the left and right does this graph go? Does it stop? No, it keeps going forever and ever and ever and ever. It's never going to stop going to the right or to the left. So type your answer in interval notation. It's going to be negative infinity. I have to click my infinity down here, comma, positive infinity, close parentheses. Okay, and that's how you That's how you say all real numbers, negative infinity to positive infinity. Let's see. Good job. Nice work. The range, how high up and down does it go? Well, it obviously goes up to positive infinity. But how far down does it go? Well, we know from that asymptote that it never goes below 0. It's never going to be at the negative. So it really starts at 0, goes up forever. Does that line ever hit the 0? No, it's never going to hit the 0. So our range is going to be 0 to infinity. But now I have to put parentheses or brackets. Infinity always gets a parenthesis. And let me move it back. Okay, the 0. Is that graph ever going to hit that 0? No. So the 0 gets a parenthesis. Which means that as soon as you jump up above the 0, you start seeing a graph. But it never quite gets to 0. All right, check our answer. I'll go with nice work again. Excellent. Okay, that's it. Oh, I can't draw a smiley face on here.